Hello students, welcome back. We are nearly done with section 1, but there's still one more topic to go. That is linear equations with decimal coefficients. Here are some simple examples, and the reason I did not bring in any more complicated example is because it's unnecessary. Why unnecessary? You'll see shortly. Now, how do you solve this kind of linear equation? Let's look at the first equation. And I named those as elementary school version and middle school version. I think I got a little bit carried away. Middle school version and high school version. Okay, that makes a little bit more sense. Okay, let's do middle school version first. That is, do the usual, flip this 2.7 to the other side, because those are like terms with this 1.3, and then dividing by the coefficient. Here we go. Here, original equation, and subtract 2.7. Okay, both from the top and bottom. And that 2.7 minus 2.7, that's gone, that's 0. 1.3 minus 2.7, we get negative 1.4. Okay, that's how you got the second line. Now from here, divide each by 0.4. Actually, excuse me. I have to divide each by negative 0.4. Okay, so negative 0.4 divided by negative 0.4, so we are just positive x. Negative divided by negative is positive. Negative 1.4 divided by negative 0.4. Negative divided by negative is positive, and we end up with 3.5. There you go. You can do that with your calculator. Sorry about this typo and the sign mistake. It should be divided by negative 0.4. Now here's a high school version. Remember that 0.4 is, as a matter of fact, 4/10. 2.7 is 27 over 10. 1.3 is 13 over 10. You see we have one decimal digit, but so denominator is 10. So multiplying 10 to each, we can remove all the decimals and we get an integer equation. Negative 4x plus 27 equals to 13. And solving this, that's a piece of cake. We have been doing that before. We got that, and then divide. We end up with, oh, wait a minute. Negative 14 divided by negative 4, so yes, 3.5. Sorry about the typo, now it's corrected. Which do you like better? I like the second one better. Even if you have a decimal equation, you can remove the decimal in the very first step. Here, I have only first decimals, so I just multiply it by 10. But if you have something else, like this, then you can change all those by multiplying by 100. Negative 45x plus 271 equals to not 13 but 130, because I multiply by 100, and then you can go from there. Here's another problem. Completed? Not yet? Stop the playback and do it on your own. Well, I guess let's go. Let's assume everybody got it done. So you can add 3.9 to each, get the second line, and divide by 2.1 from each, and then you get the third line, which is the answer. You can do those by punching the calculator. Or you can change the original equation into integer equation by multiplying by 10 to each, so that you move this decimal by 1 unit to the right. So 21x minus 39 is 87, and we do the usual. Subtract this one away, and so on and so forth. So if you have any decimal equation, you can always change those to integer coefficient equation and then use all those techniques that we went through. Number 1, denominator. Number 2, parentheses. Number 3, like terms. Okay, we went through some decimal coefficients, so let's do some applications associated to the decimals. Let's consider this. Stop the playback and read through the problem. Last year, Ike invested $90,000 to 2 investment funds. Fund A yielded a capital gain of 10% and Fund B yielded 15%. If Ike made $10,000 through these funds, what was his allocation? So how much did he invest in A, and then how much did he invest in B? Let's say X is the Fund A, then it is 90,000 minus X. That went to Fund B. Does it make sense? So Fund A and Fund B must add up to 90,000 because Ike invested a total of $90,000 in 2 investment funds, some to A, some to B, nothing else. So they have to add up to 90,000. If you name X as allocation to A, then 90,000 minus X should be allocation to B. Make sense? So that they add up to 90,000. Okay, now he made $10,000 and then Fund A yielded 10%. So he got 10% from X and then 15% from Y, from B. And then they add up to, that's the equation. Does it make sense? This much came from Fund A. X was allocated Fund A, and then yield was 10%. So 10% of the allocation. So the fund went up by 10%. And how about Fund B? It went up by 15%. But then again, how much did he invest to begin with? It was 90,000 minus X. And they add up to $10,000. It was a bit challenging to set up the equation, but here we go. And we have decimal coefficient. In application problems, decimals are commonplace. 10% and 15% in this case. Now, how do you solve this? Well, my first reaction is to remove all those decimals by multiplying by 100. So let's go ahead and do that. Multiply by 100. Multiply by 100. Multiply by 100. There you go. I already multiplied by 100 here, so no more multiplication there. I multiplied 100 there, so no more multiplication there. You have to multiply only once. You see? 100 to the first term, multiplying 100 to the second term, and multiply 100 to the third term. So okay, here we go. And there is the adjusted equation. All coefficients are integers this time. And let's solve it. 10x plus, what is 15 times 90,000? So it's 1,350,000. Okay, looks like that's a breakup. Make sense? Okay, let's take like terms together. 10x minus 5x So let's copy and paste this thing. 10x minus 5x, so minus 5x. Okay, one more step. And subtract this one away. And then 1 million minus, this is negative 350,000. And dividing by negative 5, negative becomes positive. X is 70,000. 35 divided by 5 is 7. And then put the appropriate number of zeros. So 70,000. That's the allocation to Fund A. Now, how about the allocation to Fund B? That's the allocation to Fund B. 90,000 minus X. So 90,000, the initial 90,000 was divided into 70,000 and 20,000. 70,000 into Fund A, which is a bit safer, and 20,000 to Fund B, which is a bit riskier. And in this particular year, A yielded 10% and B yielded 15%, so they added up to positive $10,000. And that's the solution. If you want to check, you can do it like this. 10%, no, let me use Mathematica. 10% of 70,000 plus 50% of 20,000. So 10% of 70,000, 15% of 20,000, and then calculate it. What's the sum? 10,000. Yes, it checks out. So we can handle application problems like these, and application problems very typically have decimal coefficients, so it's a good idea to remember how to deal with decimals. Usually the best way is to remove all those decimals at the step 1, in this case step 2. By the way, this modeling and this equation setup worked out okay in this problem, but it's not the easiest. It's not the best, not the easiest, at least in my opinion. We're going to deal with a little bit more effective way to handle this kind of problems in, let's see, in week 5, I think, when we deal with the systems of linear equations. And that's when we're going to do a little bit more modeling. For now, let's stick to the basic strategy and make sure you understand this thoroughly. Denominators, parentheses, like terms. That's the order, don't forget it, and keep applying the same technique all the way toward the end of the semester.